Hello everyone, today we are going to learn Chapter 1 Locating Places on the Earth from your Social Science textbook. In this video, I'll be covering each and every line from the chapter so you don't miss anything important. Make sure to keep your notebook and pen ready and take notes while watching. This will help you remember the concepts better. You can pause or rewind any time to write things down. So, let's begin. Understanding time zones. Let's make the globe rotate again from west to east. That is how our planet spins around its axis, making a full turn every 24 hours. A full turn is 360 degree. So this means 15 degree per hour. 15 into 24 equals 360. Let us now mark the meridians of longitude every 15 degree. Moving eastward from the prime meridian, we get 0 degree, 15 degree east, 30 degree east, 45 degree east and so on every 15 degree up to 180 degree east. It is the same as adding 1 hour of local time with each meridian. If it is 12 p.m. or noon at Greenwich, it is 1 p.m. local time at 15 degree east, 2 p.m. at 30 degree east and so on. But going westward, it is the other way round. 11 a.m. local time at 15 degree west, 10 a.m. at 30 degree west, etc. The earth spins around like a top. This spin is called rotation. It turns from west to east and it takes 24 hours, that is one whole day to make one full turn. A full turn is like turning in a big circle and a circle has 360 degrees. Since Earth turns 360 degree in 24 hours, to calculate how much it turns in 1 hour, we divide 360 by 24, which is equal to 50. So, Earth turns 15 degrees every hour. That means for every 15 degree, 1 hour passes. Now, on the globe, we draw lines from the North Pole to the South Pole called meridians of longitude. Let's start with the main one, that is prime meridian at 0 degree, which passes through Greenwich, England. If we move east from Greenwich, let's say it's 12 noon at Greenwich. At 15 degree east, it's 1 p.m. and at 30 degree east, it's 2 p.m. At 45 degree east, it's 3 p.m. and so on. And if we go west from Greenwich, at 15 degree west, it's 11 a.m. At 30 degree west, it's 10 a.m. At 45 degree west, it's 9 a.m. and so on. That is, we add 1 hour to the previous time zone when we move east from Greenwich meridian. At 15 degree east, it is 1 hour later. At 30 degree east, it's 2 hours later. At 45 degree east, it's 3 hours later and so on. Similarly, when we move west from the prime meridian, we subtract 1 hour from the previous time zone. At 15 degree west, it's 1 hour earlier. At 30 degree west, it's 2 hours earlier. At 45 degrees west, it's 3 hours earlier and so on. This system helps us know the local time at different places on Earth based on how far east or west they are from Greenwich. Let's explore. 2 friends, one sitting in Porbandar, Gujarat and the other in Tinsukia, Assam, are speaking on the phone late afternoon. The latter remarks that the sun has set in Assam and it's now dark. The former is surprised and says, but it's still full daylight here. Explain why. And as a class activity, calculate the difference in local time between those 2 cities. Hint, for now, consider the difference in longitude between Porbandar and Tinsukia to be 30 degree. Later, you can find out the precise value. So, 2 friends are talking on the phone late afternoon. One is in Tinsukia, Assam in the east of India. The other is in Porbandar, Gujarat in the west of India. The friend in Assam says, the sun has set here. It's already dark. The friend in Gujarat is surprised and says, it's still daylight here. Do you know why this happens? This happens because the earth rotates from west to east, which means the eastern parts of the earth see the sun first and the sun sets there earlier. So, since Assam is in the east, the sun rises and sets earlier there. Gujarat, being west of Assam, will see the sunrise and sunset later. That's why it's already dark in Assam but still light in Gujarat. As a class activity, we have to find the local time between these two cities. We have already learned that every 15 degree of longitude equals 1 hour time difference. Here, it is given that the difference between Porbandar and Tinsukia is 30 degree. So, we have to divide 30 degree by 15 degree, which is equal to 2. So, Tinsukia is 2 hours ahead of Porbandar. So, if it's 5 p.m. in Porbandar, it's already 7 p.m. in Tinsukia. That's why the friend in Assam is already in the dark while the friend in Gujarat still sees daylight. The same method can be used to calculate the local time of any place on the earth. But it would not be convenient for a country to use many local times. That is why most countries adopt a standard time based on a meridian passing through them. Indian Standard Time IST is 5 hours 30 minutes, also noted 5.5 hours ahead of the local time at Greenwich, called Greenwich Mean Time or GMT. So we learned that the local time at a place depends on its longitude. So in theory, every city could have its own local time, but that would be really confusing. Imagine trains running on different times in every city, schools starting at different times in nearby towns, TV shows playing at different times everywhere. It would be very hard to manage. So, to keep things simple, most countries use one common time for the whole country, which is called standard time. Each country chooses one main line of longitude, that is a meridian that passes through it, and uses the local time at that line as the standard time for the whole country. In our country, we use Indian Standard Time, that is IST. IST is based on a line that passes through 82.5 degree east longitude. This meridian goes near Mirzapur, Uttar Pradesh. IST is 5 hours and 30 minutes ahead of Greenwich Mean Time, that is GMT. This can be written as GMT plus 5:30. So, if it's 12 noon in Greenwich, England, it is 5:30 p.m. in India. So, what is GMT? GMT is Greenwich Mean Time, which is the starting point for measuring time around the world. It is the local time at the prime meridian, that is 0 degree longitude in Greenwich, London. So, if it's 6 a.m. in Greenwich, what will be the time in India? We need to add 5:30 to the Greenwich Mean Time. So, GMT plus 5:30. It will be 11:30 a.m. in India. Let's explore. Return to the two friends sitting in Gujarat and Assam. Use this example to explain the difference between local time and standard time. Let's go back to our example of two friends. Let's say Ravi lives in Porbandar, Gujarat in the west of India, and Amit lives in Tinsukia, Assam in the east of India. The sun rises earlier in Assam than in Gujarat. So, Amit sees the sunrise at 5 a.m. but Ravi sees the sunrise at 7 a.m. that is 2 hours later. This difference in sunrise times is because of the Earth's space and the way it rotates. This is what we call local time, the time based on the position of the sun in that particular place. But if we let each city to use its own local time, things will get confusing. Like TV shows, train timings, school timings, all would be different across cities. So what's the solution? India uses one standard time for the whole country, which is called Indian Standard Time or IST. This means that both Ravi and Amit follow the same clock, even though the sun rises at different times in their cities. So, if the sun rises earlier in Assam, both Ravi and Amit will say it's 6 a.m. IST when they wake up. Same time on the clock, even if the sky looks different. In short, we can say Local time is the time based on the position of the sun in each place, which can be different. And standard time is one common time used in the whole country, that is same everywhere. If you use local time, the sun rises in Assam around 5 a.m. and the sun rises in Gujarat around 6:30 a.m. But by IST, both places use the same clock time, even though the sun behaves differently in both places. So what's the difference? Local time is the time based on the sun at your place, and standard time is the time used officially in the whole country. Local time is different for Assam and Gujarat. Standard time is same for all of India. Assam's local time is earlier than Gujarat's. Standard time both follow the same IST, GMT plus 5:30. All these standard times are organized in time zones, which broadly follow the zones of 15 degree in the graph, figure 1.7. But let us consider the world map below, figure 1.8. We can see that the lines dividing the time zones are not fully straight. This is because they have to respect each country's standard time and therefore tend to follow international borders. The numbers written inside some countries are the numbers of hours to be added to GMT to get their standard times if they have a positive sign, or subtracted from GMT if they have a negative sign. We already know that the earth turns 360 degree in 24 hours. So each 15 degree of longitude is equal to 1 hour. This makes it easier to know the time in different parts of the world. Each time zone has a time that is ahead or behind GMT, that is Greenwich Mean Time. If you look at the world map in figure 1.8, you will notice that the time zone lines are not perfectly straight lines. Instead, they zigzag and curve around countries. This is because each country wants to have a single standard time, or a few in the case of large countries. So the lines try to follow country borders. They try to avoid dividing a country into too many time zones. Here we see numbers like +4, +8, -7, -10, +12. These numbers tell you how many hours to add or subtract from GMT to get that country's standard time. For example, India is +5.5, that is 5.5. So IST, that is Indian Standard Time, is GMT plus 5 hours 30 minutes. Japan is +9. So Japan time is GMT plus 9 hours. Here it is -10. So we have to subtract -10 hours from GMT. Don't miss out. From the above explanation, it may seem as if every country has one standard time. That is not always the case. Some countries like Russia, Canada, or the USA are too large to have a single time zone. The USA has 6 time zones and Russia has 11, which means that traveling across Russia from east to west, you will need to readjust your watch 10 times to align with the local time. So, do all countries have one standard time? No. It might seem like every country uses just one time for the whole country. But some countries are so big that the sun rises and sets at very different times in different parts of the country. So, using just one standard time wouldn't work well. It would be too early in some places, too late in other places. Some very large countries use more than one time zone. Let's look at a few examples here. Russia. It is the largest country in the world. Russia uses 11 time zones. That means if you travel across the country, you will need to change your watch 10 times. United States. The USA has 6 time zones. And Canada also uses 6 time zones just like USA. These countries are very wide, so they follow the rule of 15 degree equals to 1 hour. So, as you move across the country, the local time changes every 15 degree of longitude. Similarly, the globe in figure 1.9 centered on India shows standard times with respect to GMT for a few countries. Figure 1.9, a few time zones with respect to GMT in Africa and Eurasia. Eurasia means Europe plus Asia. It's one big piece of land that includes both continents, Europe and Asia. Here, you can see a globe that shows the standard times of different countries compared to GMT. The globe is centered on India. And you can see some countries are ahead of GMT. Standard times are written as plus or minus numbers compared to GMT, that is Greenwich Mean Time. The plus sign means the country is ahead of GMT. The minus sign means it is behind GMT. India's time is GMT plus 5.5. That means when it is 12 noon in Greenwich, it is 5:30 evening in India. India is 5 hours and 30 minutes ahead of GMT. China is plus 8. So, when it is 12 noon in Greenwich, it is 8 p.m. in China. Finally, while the prime meridian was fixed at Greenwich, the opposite line at approximately 180 degree longitude is called the international date line. We already learned that the prime meridian is the 0 degree longitude line. It goes through Greenwich, England, and is the starting point for measuring time around the world. But what about the opposite side of the earth? That's the line at 180 degree longitude, and it's called the international date line or ideal. The international date line is special because it marks the place where the date changes on the calendar. That is, when you cross it, the day changes. If you go from west to east, you go back one day. And if you go from east to west, you move ahead one day. It zigzags a bit to avoid splitting countries or islands into different dates. As you can see on the map, the plus 12 and the minus 12 time zones touch each other at this line. If you cross it by ship or plane, you need to change the date in your watch. If you cross it traveling eastward, you subtract a day, say from Monday to Sunday. If you cross it traveling westward, you add a day from Sunday to Monday. We said that the international date line is approximately at 180 degree longitude, as it deviates in places to avoid dividing some countries into two different days. So here we can see that the plus 12 and minus 12 time zones meet at the international date line around 180 degree longitude. If you cross the line while traveling east, for example, by plane or by ship, you go back one day. So, if it's Monday, you need to change your watch to Sunday. If you cross it while traveling west, you add one day. So, if it's Sunday, you need to change your watch to Monday. The date line bends around some countries and islands so that they don't have two different days. Remember, eastward means subtract one day, westward means add one day. Before we move on, maps are a very useful tool to represent an area of the earth, whether small or large. The main components of maps are distance, direction, and symbols. So what are maps? Maps are pictures or drawings that show us a part of the earth. They can show a small area like your neighborhood, a big area like a whole country, or even the world. To help us understand maps easily, every map has these important parts. Distance, which tells us how far apart places are on the map. Maps have a scale like 1 centimeter equals 1 kilometer to show real distances. Direction, this helps us know which way is north, south, east or west on the map. Most maps have a compass rose or arrow showing north. Symbols. Map use small pictures or signs to show things like rivers, mountains, cities, roads, and more. There is usually a map key that explains what each symbol means. Every place on the earth has a location which can be precisely defined with the help of a grid of latitudes and longitudes. Imaginary lines running from east to west parallel to the equator and north to south from pole to pole respectively. So, every place on Earth has a special location, like its own address. To find it exactly, we use a system called the grid of latitudes and longitudes, imaginary lines that cover the whole Earth like a net. What are latitudes? These are imaginary lines that run east to west, side to side. They are parallel to the equator, which is the middle line around the Earth. Latitudes tell us how far north or south a place is from the equator. What are longitudes? These are imaginary lines that run north to south, top to bottom. They go from the north pole to the south pole. Longitudes tell us how far east or west a place is from the prime meridian, that is 0 degree longitude. Why are these lines important? They help us find any place on the Earth, just like using a map or GPS. If we know the latitude and longitude of a place, we can pinpoint the place exactly. Longitude also marks the time and defines the time zones. The Earth is divided into different time zones, each about 15 degrees of longitude wide. Each time zone is 1 hour apart. So, when you move 15 degrees east, the time is 1 hour ahead. When you move 15 degrees west, the time is 1 hour behind. Longitude helps us keep the time organized across the world and know what time it is in different places. The international dateline is located approximately at 180 degrees longitude, opposite the prime meridian. Crossing the international dateline changes the date by 1 day. The international dateline is an imaginary line around the Earth located at about 180 degree longitude. It is exactly opposite the prime meridian, which is at 0 degree longitude. When you cross this line, the date changes by 1 whole day. If you cross the line going east, you go back 1 day. For example, Monday becomes Sunday. If you cross it going west, you move forward 1 day. Sunday becomes Monday. With this, we have completed the chapter 1, locating places on the Earth. I hope you found it easy to understand. If you want to see more videos like this, don't forget to like, share and subscribe to our channel. Thanks for watching. We will see you again in our next video. Bye bye.